Hi, this is Pat Moorhead, and we are live at AWS reInvent 2022 in Las Vegas. The 6.5 is back, and we are rocking it with awesome tech, conversations, and great people. Daniel, how are you?
It is good to be here. It's good to be back. This week has been compelling. Let's just say from day one, it doesn't really matter if we're talking about practical implementations of the cloud, all the way to ambitions and sustainability, and who knows, the future of data and even quantum.
No, I know, and that's a great lead in. And let's introduce our guest. Richard, how are you?
Well, it's Wednesday, so I still got a voice, but it's an amazing show. But 2.5 days in, wow, a lot of people, a lot of conversations.
No, it's great. And sometimes, in some ways, industry analysts are professional event attenders, right? We literally,
Right.
we're like a pack of clowns going from show to show. And one of the ways that I look at, kind of gauge a show is the amount of people per square foot who's walking around in the hallways. And, if I go to the Venetian, a little bit of it here at the Wynn, a little bit calmer, but this show is absolutely rocking. And I mean, totally understandable. I mean, AWS is at the epicenter of so many things. It essentially invented IaaS 15 years ago. And
Right.
one of the things that in our research and we talk to your customers is that they do so well is you have so many variations of compute and the ways of doing things.
Mhm.
And also, they're looking, some of the more future forward ones are looking at what's next. And quantum computing is absolutely what's next. I don't think there's anybody debating, is it going to be big? The only thing we're debating is is when. So
Right.
maybe a good place to start to talk is what do you do for AWS?
Um, Sometimes I think I have the best job in AWS. I'm the general manager of Amazon Bracket. Amazon Bracket is the quantum computing service of AWS. We launched a service 3 years ago at reInvent, and we've just gone through our second anniversary as a GA service. So mainstream service, making it easy for customers to knock down the barriers to adopting and learning about quantum computing. So we figure out the roadmap. We manage the decisions around which quantum hardware we think is interesting to customers.
Right.
And then I'm sure we'll get on to talk about it. Try to span a massive range of diversity in terms of experience and focus. Some people just looking for a quick win in this industry. Some people are thinking 20 years out as to where this technology is going to expand. And this is a builders conference. It's not really a marketing schmaltzy conference.
Yeah.
It's all about building. So what's great about reInvent is it's training people. It's getting people up the curve. Getting people to adopt technology. So it's a super curious crowd at this show, which is obviously perfect for quantum.
We were talking to one of his peers, Raj Pai, on the semiconductor side, and I think we had a comment that 75% of the attendees of AWS reInvent are geeks.
Absolutely.
And the other 25% are wannabe geeks. So it really is for builders. It is
Absolutely.
a place, and
that's why I think it's so valuable.
And-
because it feels like a very practical event.
but there might be nothing geekier than quantum. I mean,
That really hits new levels.
it does.
Okay.
And we've been following it. We've been close. You can follow our work. We've done a lot of episodes, done a lot of research, published a lot of opinion on it, talked to a lot. And it is, by the way, it is a mostly PhD field. It is mostly a group of very academic. Most of the conversation has been very academic. But one of the things that I've been really longing for is some people that can help democratize it. Let's start making it make sense. Let's start talking to the audience that has figured out how to take the cloud at scale and build really impressive stuff and do the same with quantum. So that to me is a lot of what Bracket was all about, was starting to experiment with all the different companies that are building different quantum computers using different quantum technologies, superconducting,
Right.
Ion trapping, atom splitting. So talk a little bit about kind of the experimentation, the process that you're going through, deciding who you're partnering with, and kind of what Bracket's really setting out to do for quantum.
Yeah, it's quantum has been on the radar of a lot of companies, obviously, for 20 years. All right, I mean, it's a potentially disruptive technology, as you said in your intro. So there's a lot of companies that are nervous about being disrupted or see an opportunity to be the disruptor. So there's a lot of interest naturally that generates. We've been debating, for 10 years whether or not and when AWS should be in the quantum, in the quantum industry. And until a few years ago, we had concluded that it really wasn't worth the time of most of our customers to focus on this technology. It just wasn't, quite enough center ground. The technology just wasn't mature enough. As I'm sure you've heard many times, we're a customers first company. We don't do stuff just for the sake of technology. We do it because customers find it useful. So for a long time, it just wasn't quite there. 3 or 4 years ago, we said, you know what? It feels like it's starting to come together. There's, as you said, different modalities, different ways to build a quantum computer that are interestingly different in terms of how they fit use cases, clearer sense of what those use cases are. And we felt it was worth the time and trouble of some of our customers, not all, to start investing in resources to really grapple with this technology and to plan for the future. Because they all have the obvious question, when's it going to happen? What sort of people do I need to hire? Which bits of my business are going to get impacted first? Is this a threat or is this an opportunity? So we launched Bracket, and I suppose the overriding goals are just to make it simpler. We think a lot at AWS about what we call the innovation flywheel, just generally trying to knock down the barriers, bring the right people together, and try and just accelerate the process. And as you said, it's a super fragmented industry. The guys that build the hardware aren't particularly plugged into the applications, and vice versa. The educators don't have easy access to the machines.
Right.
Unless you knew a physicist, or were prepared to spend, potentially millions of dollars a year to get access to one of these devices. If you're a corporation, you couldn't get your hands on these systems. All different commercial model, different developer toolkits, different user experiences, super fragmented. So in a sense, it sounds almost a bit cheesy, but we think of Bracket almost like the town square for quantum computing. We want to bring the hardware guys, the software guys, the consultants, the educators, the researchers, corporate users together in one place. If you can take away some of the barriers, then perhaps you can accelerate innovation and just get there quicker. And that's what we're all about.
Yeah, so not only are there different modalities in the core technology, which, by the way...
Which is a scary word for some people.
No, I know, but what I do love is I think we all realize in the industry that not one single technology is going to rule them all, right? And in fact, I like to make parallelisms to things that have happened already, and let's take GPU compute, right? Not all solutions are best for different model sizes. Some favor, one is gigantic models. We have training, we have inference, and we have everything. We have everything in between. And there's also different familiarity with the technology that on the AI and ML side today. Whether you want to go to the metal, right, and you serve up hardware, or you want a completely abstracted SaaS app with Textract or something like that, you have it.
Yep.
It looks like you're trying to build with Bracket opportunities for different levels of experience for people to be able to experiment. Am I reading that correctly?
Yeah, you're absolutely. And that word experiment, that is the key word. There's a lot of mythology in this industry, as I'm sure you've detected.
We've hit quantum advantage. We're done.
Or
3 years ago.
Quantum supremacy.
Sorry.
This is still at the research stage. Companies are not using quantum computers in production systems to save money or do stuff faster. We're not quite there yet, and we might not be there for a while. But that's not to say there's not value in getting started. This is radically different stuff. It is applicable in a certain set of use cases, radical different set of skills. This is not something you pick up overnight. Our job, of course, is to break down some of those barriers. So you don't need a physics PhD to actually do this stuff, but still, it's a curve, and you need to get started. But yeah, you're right. Some customers really want to be abstracted away from the hardware. They don't necessarily care how you build your qubits. Fair enough. But some other folks actually literally want to get in and play with the microwave pulses that literally control, the atoms on the chip. So, we just launched some features in that function in that area, so we could perhaps talk about that later. But it's a tool stack, and it gets thinner the higher you get. A lot of the partners we're working with are trying to close the gap between the hardware layer and the actual use cases, the things that people actually have problems doing today that we think quantum can solve.
It reminds me a little bit. I see parallels with AI and HPC. I know it's different state of maturity, but there was a period of time. I remember meeting someone that was like, I got a PhD in AI in the 70s. And I'm like, whoa, like it was 50, 40 years before that really started, that theory. And so, quantum, obviously we're in this stage now where people are starting to realize there's certain genomic challenges that it's going to be able to solve. And so you're seeing large pharmaceutical and biotechnology companies investing. They know that eventually they're going to want to be there, or financial services firms that want to be able to use it for anti-money laundering and fraud, and understand that heterogeneous relationship between quantum and classical is going to be a game changer.
Right.
But what you said is really great, is more experimentation now. Like the work they're doing, they could still do it faster on a HPC with what they know today. But they know in the long run they're going to be able to do it faster tomorrow. So, these people you're working with, these personas, these are almost like the innovation labs inside of big corporation, governments, cities. Like talk a little bit about that. Who are the people that are like locked in the lab right now, plugging into Bracket, starting to figure out how to make this work, in that parallelism of moving away from classical to what I think is mostly going to be a marriage of quantum and classical in the future.
Yeah. I mean, and I think that's one of the sort of the myth. Again, one of the preconceptions. It's not a myth that somehow a quantum computer is a supercomputer. It's just the next biggest machine that somehow replaces existing classical hardware. That's not the case at all. Quantum computers are really co-processors. They do certain sort of mathematical functions. In the end, we think better than classical machines, but they don't do everything. You're not going to be running a spreadsheet, or video rendering on a quantum computer. So it's always about a classical world.
Where's the keyboard?
You know what I mean? It's in the same way we think about a math coprocessor or a crypto coprocessor. It's been developed.
How about a GPU as an example of that, where it's API driven? I mean, listen, the original AI algorithms or ML algorithms were developed in the 60s. The problem is it took big data to do machine learning, and it was too expensive, and we didn't have the accelerators to be able to train it and do inference. And then the folks at the University of Toronto came up with this ability to find images, right? I saw, GPU vendors, by the way, I work for one, a GPU vendor, and I saw, banging our heads against the wall, trying to find to use this thing, something other than playing games and or doing, 2D drawing. Is that a good analogy that we should look at how this, where quantum is the accelerator and classic computing is running a set of the application?
I think it is. Yeah, I think it is. I think you can imagine, an HPC workload today that's struggling in certain areas. You can imagine leveraging a quantum computer in the same way it would leverage other instance types and use them in parallel, and manage a workflow across a variety of resources, some of which are quantum, most of which are classical. So the notion that at some point there'll be GPU, CPU, QPU instance types, it does make sense. Yeah, don't think it's calling it a quantum computer is almost a misnomer. You should think of it much more as a quantum processor for doing a certain set of things. And what we're doing now, obviously, is enabling customers to explore what those things are and to ultimately figure out how do you coordinate a workload that spans these different processor types? How do you actually formulate a problem so this bit of the problem can go onto a quantum machine, this bit of the problem should stay classical? And how do you actually orchestrate the workflow between those things? Because look at AWS. It's effectively an infinite pool of classical resource. Quantum computing is not there. These are individual machines that aren't even alive, for most of the day. So you've got very different operational characteristics. So organizing, what we could think of as hybrid algorithms that have quantum and classical components, actually managing those workflows and orchestrating these things together is not so simple. And that's what Bracket does. We don't just provide access to quantum computers, but we actually manage that interplay between classical and quantum compute.
So, go ahead.
No, I was just, you got me thinking. So I kind of hit you on the personas.
Okay.
And
which I don't think I ever.
I don't
really
think you ever really got to. But I'm gonna join two thoughts together, because I think it's going to be persona plus enterprise, because these personas are being hired by these companies, universities, these government entities, and they're asked to explore. Amazon and AWS is kind of that company that says, we want to meet our customers. You're the customer obsessed, meet the customer where they are. So you've gotten into this business because there's a journey going on.
Absolutely.
And so I'd love for you to sort of align that journey of the enterprise, the persona, and how it's all kind of tying together, that you're helping them get there. Like, because there's got to be they got to be coming to you saying, all right, we know we need to do this, help. Kind of, how do you take them through that journey?
there's a couple of different ways. Some enterprises, I think of them as sort of the quantum pioneers, right? They're doing exactly that. They're recruiting professors from universities and creating teams, significant teams in their organization.
Typically within the research group of the CIO or the CTO,
Yes.
right?
Big banks.
Yes.
and,
Yes, exactly. So they are scouting their organization to find the use cases and try and just to get ahead of that curve.
Yeah.
Some companies, they hear about quantum, they're intrigued by quantum. They come in, they want a quick assessment. Is this a quick win for me? Right, I've got problems to solve. I'm busy.
That's easy. The answer is no.
Right, which is most companies. They have day jobs, and oftentimes the conversation will say we'll pivot to quantum's interesting. You should keep an eye on it, and this is how you should do so. But in the meantime, we can make your classical stuff just go better. Oftentimes, surprise, surprise. Not everybody's maxing out what they could achieve classically. So a lot of that conversation turns back to classical technology.
It's an $80 billion business for you guys now.
And growing quickly. So some people hyper-focused, they are leading us in many ways, and part of that obsession is to listen to what they tell us in terms of evolving the service. We do have a professional services team. We launched it at the same time we launched the Bracket service. We call it the Quantum Solutions Lab. So that's sort of it's within the AWS ProServe organization, but it's a specialist in quantum computing. So it's entirely staffed by quantum PhDs. And really that's geared to corporations that really want to dig in, collaborate around algorithm development. In addition to that, we have a lot of partners, a lot of software partners. It's sort of interesting in this industry. Everyone focuses on the hardware because it is super cool, right?
And
the way these machines work is amazing.
Right?
Awesome pictures. They definitely have the best pictures. But people don't often think about the solution guys, the sort of quantum software providers. Different folks, different skill set, don't really know anything about how to build a machine. But boy, can they close the gap between the machine and the use case. So, there are dozens of software partners that have come out of the woodwork since we launched Bracket. And, our proposition to them is, it's an operational platform they can actually build a service on themselves. But also it gives them the choice. It gives them different instance types. And they tend to be very industry focused. They'll be focused on chemistry problems, or they'll be focused on application problems, or financial, fraud detection, sort of things you were talking about. They oftentimes are the first interface to corporations because they're intrinsically solution oriented, right? And they can, in some cases, bridge the gap between quantum future and classical now, and they can start taking those customers through that journey in a way that Bracket is. We're still sort of at the infrastructure layer. That will evolve over time, but now we're really, really keen on building that community of software experts to find those chinks of light in terms of where this technology really fits into different industries.
And by the way, that's how GPU compute started,
Exactly.
right? I mean,
exactly.
And now look where it is today. I mean, it's evolved and it's delivering incredible value. I wanted to shift the conversation to academic research and open source. So as far as I can remember, some of the biggest breakthroughs have been driven by research. And I always like to clarify, don't confuse R&D. I know we say R&D, but research is very different from development. Research has higher risk, has a higher failure rate, but boy, when it hits, it hits. And if you look at whether it's wireless technologies, compute, storage, I mean, anything that was huge out space, right, came from first research, and then we answered a bunch of questions, and then we got development. A lot of that research is done through academic institutions for quantum. In fact, every company seems to be aligned with an academic research
oftentimes
group.
it's direct spin out.
Exactly, and there's funding. And then you have open source, which at least in the past 20 years has been this growth multiplier where the promise is you make some improvements and share it with everybody else. You can take advantage of all the improvements that they put in. And AWS has been basically built on open source software. So I'm getting to a question here. How does Bracket help these two audiences academic research and also the folks dealing in open source?
I mean, the research piece, is essential, and it's good that you drew the line between R&D, because
Drives me a little crazy, I'll admit.
yeah, I mean, there's a lot of engineering work going into building quantum computers these days, but we should never forget that to get to the point of a fault-tolerant quantum computer, there are significant scientific advances still to be made. There's Nobel Prizes to be had
Yes.
in this area. This is not done and dusted. This is not just making it faster and cheaper, right? So one of the primary use cases for quantum computing right now is figuring out how to build better quantum computers. Fundamentally, so a lot of researchers out there are diving into really, I think, two areas. We have the dream of delivering a fault-tolerant quantum computer, which we know can deliver exponential compute power. But we don't have one of those machines yet, and we might not for a while. So in the meantime, we're living with these error-prone, noisy machines. People have coined this phrase NISQ, noisy intermediate scale quantum,
Right.
which is a way of saying we're going to use classical computers to make quantum computers work better in the near term. In the long term, we think quantum computers make classical computers work better.
Entanglement.
Right, but for the next, who knows, 5 years, maybe longer, classical computers make quantum computers work better, which is what NISQ is all about. So we have researchers that are absolutely focused on, the long-term game, error correction. Quantum error correction is sort of the elephant in the room. We sort of have to fix that problem. There's no point in, chunking out 1 million qubits of today's quality. It just doesn't get anywhere. You just simply couldn't use them. So we got to fix the world of error correction, and there's a ton of research going into that. And part of what Bracket does, some of the functionality we talked about, the stack, the reason why you want to dive down the stack is so you can research error correction. So you really can understand how these qubits actually interact, at the physical level. The other area of research is the near-term stuff, is NISQ. Is how can we think about, almost the notion of a self-training quantum algorithm. We used to trade the concept of training, obviously machine learning, but you can take similar approaches, sort of iterative, convergent processes to enable quantum algorithms to be tweaked over time to better deal with the error profile that they see on machines that they're actually working with. So there's a whole discipline of figuring out what these hybrid or variational algorithms actually look like. So a lot of researchers are in that space because that's where the near-term win is. That's potentially the route to, quantum advantage. And there's endless debate in the industry as to whether that's ever going to be fruitful. But you sort of have to try, because if it's not going to work, you just have to wait until a fault-tolerant quantum computer comes along, which might be a while. So in the meantime, we have to see what value we can squeeze out of current devices. And that's all about, again, sort of lassoing together quantum and classical resources. And as quantum computers get bigger, that amount of classical resource to support the quantum computer gets bigger quickly because there is this exponential gap. And if there wasn't, we wouldn't be bothering building these machines, right? So people shouldn't think of a quantum computer in isolation. You don't sort of go behind the curtains and, tinker with the device. Mm-hmm. It's all about really how you bring these resources together. And today that's at sort of an algorithmic level. How do you get around these noisy devices? But over time, that hybridization exists at the sort of HPC level, right, where you have a general problem that you're then distributing across a wide variety of devices.
Yeah, I love what you say about the quantum computing as a whole, not thinking so much about computing, processing. We've been in rooms with ion trapping machines. We've been in rooms with superconducting. It is not, you're not, it's not flipping open a laptop.
Is this on?
And I say that because, I think there's still a lot of that kind of misconception. And one of the biggest opportunities still is to just sort of break that mythology between the average person and what quantum can be. And then, of course, all this stuff happening that you mentioned in research. And then eventually it comes. Like you said, the early classical computing machines were very different than what we see today. And that same type of evolution, it'll probably happen faster because of how fast technology is moving. But more than anything, Richard, I want to thank you for joining us. This topic is not over. We have many more conversations, and I'm hoping they'll be with you. That we can bring here to kind of talk about the progress, because this is one of those things that every year there's progress being made, whether it's more fidelity, more quantum supremacy, but I personally like more usability and
Right.
realistic examples of software, of cryptography, things that are going to be done with quantum that companies
And that's why it's in the
see
cloud.
today.
I mean, that's fundamentally
exactly
why
why.
we felt it's really, really important to deliver Bracket as a cloud service within Bracket, because it's all about leveraging the quantum computer in the context of the platform, in the context of all of that compute resources. You know, our large corporate customers, they live and breathe, right, the AWS platform. They like the tooling
Right.
that exists. You know, when we launched Bracket, it was really important that we adhered to all of the security mandates, you know, operational mandates, the integration with the various tools and services that are across the entire ecosystem of AWS, and customers love that. You know, they want to be able to control access to these resources, just like they want to control access to databases and EC2.
Well, Richard, thank you so much for joining us. We got to end there.
You're welcome.
Really appreciate having you at AWS reInvent for 6.5 on the road at this event. Great guest, great conversation.
Yeah, it was fun. It's great.
There's so many more of these to be had. If you're out there and you're watching, we have several more of these conversations. Go ahead and click that subscribe button. Join us for all the episodes here and all our other episodes. We love having you as part of the community. But for this one, time to say goodbye.
Thanks, everybody.
See you later.